students. In this session, I am going to discuss previous year questions D and F block elements. The clear content explanation I had given by previous videos. D block elements I have done 3 parts. F block elements I have done 2 parts. So while explanation concept I have covered theory questions more. Now same theory questions only, but little tricky questions. Some questions are there. So previous year NEET questions and mains questions I am going to discuss in this session. So, okay, let's begin with first question. Transition element. Transition element X. Transition element X has a configuration, electronic configuration, has a configuration argon 3d4 in its +3 oxidation state, in its +3 oxidation state. So its atomic number is, this is previous year question, its atomic number is, your option students, first one 22 and second option is 19, third option 25, fourth option 26. Okay, how to solve such type of questions? Look into this. Argon 3d4. That here they mentioned transition element. Okay, transition elements 3D series we have, 4D series we have, 5D series we have. But argon means, argon 3d4 means it is 3D series, students. 3D series C. Here, what is the general electronic configuration of 3D series? If you look into scandium, scandium atomic number is 21, argon 4s2 3d1. So this is common for all transition elements except chromium and copper case. One electron exchange is there, chromium copper, while explanation had given, and electronic configuration videos also I have uploaded. There I gave clear explanation. So here, this is general electronic configuration of 3D series. 4s2 is common except chromium and copper cases. This 3D. So here 1, here also 1. Here titanium means 2, like vanadium 3, like that manganese 5 number means 5, like that easily we can write. This is first point. We have to write general electronic configuration, one particular element. Next one, what is this? Element X has configuration argon 3d4 in its +3 oxidation state. That means that metal, he lost 3 electrons. Then only it reaches the M +3 oxidation state, right? So where it will lose electrons? Definitely outermost shell. Which is outermost shell here? Highest principal quantum number. Just highest number 4s2. This is outermost shell. Outermost shell, how many electrons there, students? Yes, 2 electrons. 2 electrons we are removing from 4s. Okay, 3 electrons removing for 4s. And the next one from 3d, 1 electron it lost. That is the meaning. So, okay, now look into the question. Suppose I am taking example 3. Option 25 they gave, no? See, manganese. To understand concept, I gave scandium general example. Now I am going to the question now. Manganese, argon, 4s2, 3d5. See students, Mn +3 state. Mn +3 state means where we have to remove electron? 4s. Yes, 4s, 2 electrons gone. Afterwards, remaining 1 electron, where I have to remove? Yes, here I have to remove 1 electron. Then what is the rest condition here? Tell me. Argon 3d4. So finally what is our answer, students? Option 3. So each and everything you can pick it. Suppose scandium. Titanium is 22. Right? So what is this? Argon 4s2 3d2. If it lose 3 electrons, 3d1 only there. But 3d4 they had given, no? Like that each questions we have to select. It is ion. This is manganese. This is potassium. It is not transition element. Leave it. So this is not matching. Ion also. Manganese is matching. This is your answer. Answer 3 is correct option. Okay, so just add 3 electrons, but where we have to add important, don't add only 3d, 4s also we have to add, because while removing electron 4s only, no. So hope it's clear. Now going to the second question, students. Question 2. When neutral are or faintly alkaline KMnO4 is treated with Ki, potassium iodide. So iodide is converting into X. Iodide is converting into X. What is X? What is X? This is your question. So options they had given here. So first option I2, second option IO4 minus, and third option IO3 minus, fourth option IO minus. See students, KMnO4 in acidic medium or basic medium acts as strong oxidizing agent. But if you maintain acidic condition, I minus, iodide converting into I2. But if you maintain basic condition or neutral condition H2O, it is converting into IO3 minus. Important point. Important note point, students. If you have command directly, you can remember, or else equation also there. Look into this equation. What is this? KMnO4 reacts with KMnO4 means your potassium is spectator. No, you no need to use. Just to ionic form we can take it. MnO4 minus plus H2O plus I minus gives rise to MnO2 plus 2OH minus. This is what? IO3 minus. This is one of the frequently asking question. See, neutral condition or basic condition means I minus is converting into IO3 minus, -1 oxidation state to +5. Here also undergoing oxidation, acts as oxidizing agent only, but product is varying. Here I2 -1 to 0, here -1 to +5. Oxidation states also they are asking. Clear, students? Okay. Now going to the next question. Ionization energy. One of the common question in inorganic chemistry, ionization energy. The correct order of decreasing second ionization energy of titanium, next vanadium, next chromium, manganese they had given. So I am not giving options, students. Directly we can work out this question to save the time. So correct order of decreasing second ionization energy. First ionization energy, second ionization energy. As we move across the period, students, ionization energy. What happens, students? Ionization energy increases. Why? Because atomic radius decreases. Atomic radius decreases means ionization energy increases. Okay, as we move across the period. First, we have to list out this element in the correct order. So first, who will come? Scandium, next to titanium, vanadium, chromium, manganese. In our list, titanium, vanadium, chromium, manganese is there. As we move across the period, what happens, students? Size decreases, ionization energy increases. So which is having more? Manganese. Is it correct? No. Wrong. Here what is the exceptional case, students? See, chromium. Chromium, copper is there means we have to focus more. See, chromium, argon, 4s1, 3d5. So first ionization energy means here we are removing. This is chromium plus argon 3d5. Now I am going to the chromium plus 2 state. That means I have to remove from the exactly off-filled electronic configuration. Exactly off-filled, completely filled electronic configurations are stable. No? Definitely ionization energy is more. Ionization energy requirement is more. IE is more. So important point. So similar like you can take it manganese. Manganese, what is the students? Argon 4s2 3d5. So manganese plus state. Plus means your one electron, only one electron gone. Argon 4s1 3d5. So here also off filled only, but when compared to D, S is less stable. So here removing electron is not much difficult, not much difficult. We can remove 3d5. Then third ionization energy of manganese is dominating. So like that, depends on question students. Second ionization energy of chromium is greater than second ionization energy of manganese. But if they asked question, third ionization energy means here, where you are removing here, this is exactly off-filled. This is not exactly off-filled. Then third ionization energy of manganese is greater than that of the third ionization energy of chromium. So this ionization energy question plays important role, students. If you have command in electronic configuration, then only easily we can work out. Please go through our channel electronic configuration separately. I had explained 4 different methods. Once you will get command, I gave logics also how to remember, then come back to the question. So finally, what is your answer, students? What is your answer? First one is chromium, then manganese. Your exceptional case. Remaining is as it is. As we move across the period, what happened? Ionization energy increases, no? Vanadium more, titanium is less. This is your answer. Okay. Now, next question. Next question, fourth question. Oh, which question now? Number, yes, fourth question. Here they are asking colored, colorless. You have good idea about color and colorless, no? In previous video explanation also had given. These are the common questions they are asking. How easily we can work out. Now look into this. In which of the following, pairs are both the ions colored in aqueous solution. Students, I am giving options pairs here: nickel plus 2, copper plus 1. So next one, nickel plus 2, titanium plus 3. And option 3, scandium plus 3, titanium plus 3. And fourth option, scandium plus 3, cobalt plus 2. How easily we can work out question C. Scandium plus 3, Zn plus 2, copper plus 1 are colorless. Due to, what is the reason? Due to the absence of unpaired electrons. No excitation, no unpaired electrons, no excitation, and magnetic moment also 0, students. Okay, just I'll show one example here. Scandium, atomic number 21, argon 4s2 3d1. 3 means it lost 3 electrons, no? 3 electrons means 4s gone, 3d also gone. After that it can reach the argon state. Here no unpaired electrons. If there is no unpaired electrons, definitely colorless, right? Colorless, and magnetic moment also 0. I am covering another question also here. Same like Zn plus 2 also colorless, copper plus 1 also colorless. Okay, that's it, students. Copper plus 2 again colored. N equal to 1. One unpaired electron is there also. It shows color, blue color. Okay, color, aqueous condition. Copper sulfate pentahydride, it is blue vitriol, blue color. See, here copper combination is there. That's it. This is not your answer. Here, okay, nickel plus 2, titanium plus 3 colored. I can show. See, scandium plus 3. So this is not your option. Scandium plus 3. So at least one is matching. Your answer is finding. It's very easy. Answer finding is very easy. Right. Now I can show. Nickel plus 2, titanium plus 3. nickel, atomic number 28, argon, 4s2. This is what is the number 8. That's it, 3d8. 2 means, nickel plus 2 means where it lost electrons? Here. Argon, 3d8. So 3d8 means you can write box method. After writing box method only, you have to find out number of unpaired electrons. 1, 2, 3, 4, 5, 6, 7, 8. This is box method according to Hund's rule. Here n equal to 2. N is nothing but unpaired electrons. Unpaired electrons. So at least one unpaired electron is there, it can show. But if here two unpaired electrons, so definitely it shows color. Green color like this nickel plus 2 solves. Unpaired electrons, definitely color. Next same thing, titanium, right? Titanium plus 3. So what is the titanium atomic number? Scandium, titanium, 22. Argon, 4s2 is common, I said. Then this is what? 3d2. So for here 2 electrons, here just 1 electron. This is 3d1. 3d1, n equal to 1. 1 unpaired electron is there. Definitely it is colored. Colored. And magnetic moment value also just 1.73. See students, what is the n value? The same magnetic moment value also. Suppose previous videos I had explained, if n equal to 1, mu equal to 1.73, n equal to 2, mu equal to 2.8. If n equal to 3, same number, just 0.8 you can add. Only one case, first case 1.73, remaining all the cases 0.8, 0.9, like this. In previous video also clearly had explained this concept, 5.8, 5.9. That's it. Sometimes they may ask colors, sometimes they will ask unpaired electrons, sometimes they will ask magnetic moment value also. Here what is the magnetic moment value? Just 2.83 Bohr magneton. Sometimes they will give magnetic moment, they will ask you how many unpaired electrons. Sometimes they will give n equal to 2, what is the magnetic moment value? All the questions easily we can work out. Okay. Now what is your option? Yes, second option. So deleted options, if you have command, no selection option is very easy. Sometimes two answers, it is nearly matching confusion. Then you go for calculation, find out your correct answer. Clear students? Easy, no? Very easily we are working. Okay. Now next question. Next question. Magnetic moment magnetic moment 2.84 Bohr magneton. I think this is fifth question. 2.84 Bohr magneton is given by, just now I gave explanation, right? Your options, chromium plus 2, second option, cobalt plus 2, third option, nickel plus 2, and the fourth option, titanium plus 3. See students, nickel plus 2, just now we calculated, no, unpaired electrons is 2, 2.8 answer, 2.83 or 2.84. That's all. Within minute you will get answer. Your answer is nickel. If you want, you can check it. Chromium 4s1, 3d5, exceptional case. Chromium plus 2. Plus 2 means here 1 electron, here 2 electrons, 3d3. 3d3 means n equal to Bohr magneton is 3.8. It's not matching. Next, cobalt. Cobalt, argon, 4s2, 3d7, cobalt 27, right? So students, if you have command at least 3d series, so then easily we can work out D block elements questions. From 3d series only you can expect more questions. 4d series, 5d series also important, but zirconium and hafnium, similar atomic radius theory questions, it is easy. But here, if you don't have command atomic numbers, all questions feels very difficult. So better to learn 3D series scandium to Zn with including exceptional cases, cobalt plus 2 here. That's it. So here n equal to 7. You can take like this. Wrong. N equal to not 7. 1, 2, 3, 4, 5, 6, 7. N equal to 3. If you write box method, then only will come to know. Here also answer is 3.8 Bohr magneton, not matching. So same like titanium plus 3. Just now we calculated, no? Titanium Scandium, titanium, argon, 4s2, 3d2 here, n equal to 1. 1 equal to 1 means Bohr magneton is 1.73. So your answer is third option, 2.84. See students, these are common questions in D block elements. Any competitive exam, Comet K, KSET, NSET, mains, NEET examination, all very easily we can work out. Okay, still if you have any doubts in concept also, go through the concept first, our videos, then come back to the questions. Now, next question. Basic character of the transition metal. Basic character of the transition metal. Monoxide follows the order. Okay, just they gave elements. Titanium, they gave vanadium, they gave chromium ion. Students, we know 1 point. What is that hint point here? Hint point here, as we move across the period, what happened? Basic nature decreases. Simple logic. So scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. But they give titanium, vanadium, chromium, iron. You have to pick out. So first you write the 3D series. As we move across the period, what happened? Basic nature decreases. The two monoxide, titanium oxide. Okay, then greater than vanadium oxide, the two greater than chromium oxide, the two greater than iron. There are no exceptional case. That's all. That is your answer. Electronic configuration exceptional, but basic nature no exceptional. Now, next, going to the next question. See, this is a little tricky question, but very important question. Question number 7. Which of the following ions exhibits DD transition and paramagnetism as well? Your options: chromate, CrO4 2 minus chromate. Next, dichromate, Cr2O7 2 minus dichromate. And another example, MnO4 minus, this is permanganate. And next one, MnO4 2 minus, that is manganate. See, go back to the question. Which of the following ions exhibits DD transition and paramagnetic? See students, if any ions or any species which is showing paramagnetic nature means, what is the reason here? What is the reason? What is the explanation? What is the hint point? Unpaired electrons definitely shows paramagnetism. Okay, paramagnetic substances. Suppose DIM. Suppose if you take 3D, how many boxes students here? 5 boxes. 1, 2, 3, 4, 5. So whenever ligands approaches, ligands is nothing but donating electrons. Ligand approaches, then what happens? This 3D go to the excited state. Okay, still it is approaching, then what happens? It splits into 2 parts, 2G set and EG set. This clear explanation I am going to give in the coming video, that is coordination chemistry, crystal field splitting. When splitting happens, whenever ligands is approaching the 5 degenerate orbitals. This is 5 degenerate orbitals, no students. This 5 degenerate orbitals is splits into 2 parts, 2G and EG. This is triplet, that is doublet. Octahedral splitting and tetrahedral splitting variations are there. Clear explanation coming days we can do. What I am trying to say here one unpaired electron is there. So at least one unpaired electron is there. This unpaired electron now starts excitation. Whenever electron absorbs energy, it will go to the excited state. It will come here. And excited states are generally unstable. They're coming back to the lower states. The lower states time the releasing energy. That releasing energy, if you send into any glass plate prism, it colors. The output only we call it as colors. Finally, what is this? Unpaired electrons is the reason. And the second point, inner DD transition. What is this, students? Inner DD transition. See, so DD transitions and paramagnetic both are there. Definitely it can exhibit the color. Clear? But now among the four options, in which case we are getting unpaired electrons, we have to calculate. That is your answer. That is your answer. After explanation, I will give the charge transfer also. This is one of the common questions. See, CrO4 2 minus. In CrO4 2 minus, chromium oxidation state is plus 6. Right? So this is X plus 4 minus 2 equal to the charge. Each oxygen minus 2. X minus 8 equal to minus 2. X equal to plus 6. Chromium plus 6. Chromium plus 6 means what is atomic number? 24. Outermost argon 4s1 3d5. See, 6 electrons gone. After 6 electron, chromium plus 6 argon state. Here completely filled argon is N equal to 0. No unpaired electron. No DD transition. That is not your answer. And go for the next option. What is this? Chromate and dichromate. In previous video also had given chromate and dichromate are interconvertible. If you maintain acidic condition, it converts into dichromate. If you maintain basic condition, it converts into chromate. So is common question. Here also chromium plus 6 oxidation state. Same thing. Here also N equal to 0. N equal to 0. So calculate oxidation state. Next one. Yes. What is the next example? MnO4 minus. Here manganese plus 7 oxidation state. So X plus 4 minus 2 equal to minus 1. X minus 8 equal to minus 1. X equal to plus 7. Manganese, what is atomic number? 25. Argon 4s2 3d5. 5, 5. That's it. So 7 electrons gone. Here also no unpaired electron. First three options is not correct. Definitely your answer is the last one. Okay. But we have to find out if correct or not. This is manganate. MnO4 2 minus. This is what we call it as manganate. Okay. Here manganese oxidation is plus 6. Here minus 1 means plus 7. Here you will get plus 6. X plus 4 into minus 2 equal to minus 2. X minus 8 equal to minus 2. X equal to plus 6. Clear? That's it. Mn, now take it to argon. Next 4s2 3d5. Here 2 electrons gone and remaining 4 electrons here. This rest is 3d1. N equal to 1. At least one unpaired electron is there. It will go for the transition and paramagnetism also it can show. Clear, students? So finally, what is our answer here? What is our answer? Yes, last option, that is manganate ion. Permanganate or manganate? Manganate ion. This is your answer. Clear? Next, even chromate. Students, I am writing down here points. These are all colors. These are all colors. Even chromate also, what is this? Yellow color, dichromate orange color, and permanganate purple color, and this is green color. Why? These are all showing colors. So see, above examples also shows colors. What is this? Chromate. Suppose chromate ion is there. Yes, chromate ion, N equal to 0, even though it is showing color. Color. Why it is color? Due to charge transfer. Due to charge transfer. What is this charge transfer? I can show. This is a yellowish color. Yellow color. Next to dichromate, Cr2O7 minus. This is orange color, orange red, orange color. So here also charge transfer. Okay, DD transition also colors and charge transfer also colors. Next, MnO4 minus. Yes, this is one of the good example. Even practicals also we are doing purple color. Purple color. Why here n equal to 0? No, how it can show color? Look into this. Look into this. MnO4. In previous classes, I had given one question. I'll explain. Remaining all the same logic you can apply, students. Now MnO4. Mn. MnO4 minus. This is tetrahedral structure, right? So draw the structure first, and then this is out of 4 oxygens, 1 oxygen in negative charge, right? Double bond O, double bond O. This is O minus. O minus. Now manganese, what is oxidation state? +7. Here 4s2 3d5, right? So both gone. So finally metal have vacant orbital. D now vacant. So vacant orbital here only, along with metal vacant orbitals are there. So 3d is there and 4s also there. Now what happened is the vacant orbital now ready to accept electrons. Ready to accept electrons. He is negative charge, he is ready to give electrons, electron rich, electron deficient. Like he is giving electrons, charge transfer. Because of this charge transfer, it shows color. Charge transfer takes place. That is why it is purple color. Last questions. Among the following, which is colored due to charge transfer, due to unpaired electrons? The last questions like that. So this is one of the most important frequently asking question in D block element, students. Is it clear? Now going to the next question. 8th one. The correct order of ionic radii of yttrium plus 3, lanthanum plus 3, europium plus 3, lutetium plus 3. Correct order of ionic radii of this. All are plus 3 species. So what is the logic point hint I am giving? First, as we move down the group, what happens, students? As we move down the group, size increases. Yes. And as we move across the period, what happens, students? Across the period, size decreases, right? So that's it. Now you apply the same logic. So if you look into 3D series, scandium, titanium, vanadium, chromium, manganese. Only few elements I am taking. Few elements, with few elements help we can write this question answer. Yttrium, zirconium, niobium, molybdenum, technetium. What about 5D series? It starts with lanthanum, hafnium, tantalum, tungsten, rhenium, like this, right? So now look into this. So first of all, the given species position in the periodic table where it is, definitely you'll come to know the answer. See, this is lanthanum. This is lanthanum. Where is lanthanum? Here. Yttrium here. So as we move down the group, what happens, students? What happens, students? Size increases, right? So here, yttrium to lanthanum, what happens? Size increases. Means yttrium is the least size, less size when compared to lanthanum. Okay, fine. You found this answer. Next, europium and lutetium. These are after lanthanum. Cerium to lutetium are 58 to 71 are lanthanoids, right? After lanthanum, only lanthanoids will come, no? That we are studying across the period, right? So finally, what I'm trying to say here, lanthanum is greater size. After lanthanum, only lanthanoids will come, right? So that's the reason first one is size is lanthanum plus 3. Afterwards, lanthanoids. Lanthanoids also in our hand. Europium is there, lutetium. Lutetium is the last one. Lutetium is the least size when compared to the europium. Europium is the middle one. Sometimes they will ask gadolinium. Europium, gadolinium means europium will come first, then gadolinium, like that. Now, next one. Last one is yttrium. Okay, if you have command at least the first one and last one based on options also we can go for the selection. Okay, so this is easy but little confusing. When little confusing, if you don't have command position of the elements in the 3D series, 4D series, 5D series. Okay, so look into this question. After that you can feel definitely easy. Now, one numerical part they are asking students. Are you able to work out or not? Check it. KMnO4 KMnO4 reacts with oxalic acid according to the equation. According to the equation. So write down what is the equation. 2MnO4 plus 5 moles of C2O4 2 minus oxalic acid H2C2O4 actually, but they have taken ionic form. Here also permanganate ionic form. So it is in the presence of acidic medium. Yes, reaction also they had given. 2Mn plus 2 oxidizing agent means itself it is reducing no plus 5 to plus 2 and oxidizes the neighboring group carbon plus 3 to plus 4 state 8 moles of water. Okay, here they gave one more information. Here 20 ml of 0.1 molar KMnO4 is equivalent to Okay, so what is the students? What options also they gave? Options also they gave. What is the option? What are the options they had given here? Yes. First option 50 ml. 50 ml of 0.5 molar C4, that means oxalic acid. Next 20 ml of molar H2C2O4, that both are same, C2H2O4, H2C2O4. Next 20 ml of 0.5 molar H2CO4 and 50 ml of 0.1 molar H2C2O4. That's all, students. Okay. Now go back to the question. KMnO4 with oxalic acid, some reaction they gave students. Okay. But here what they are asking, here 20 ml of 0.1 molar KMnO4 is equivalent to. So volume they gave, molarity they gave. The given question, if you convert into number of moles, easily we can work out. Equivalent they are asking, no? Normality you can express, molarity, answers all are in molarity only, no? Molarity wise you can take it. What is the formula? Molarity equal to number of moles of solute by volume liters. Here molarity, how much they gave starting? 0.1 molar KMnO4 they gave, right? And next one, volume, how much? 20 ml they gave, students. But we have to convert into liters. 20 by 1000, right? So 2 by 100, right? So that is nothing but 0.02 liters. Then you can substitute molarity 0.1. Now number of moles you can calculate here 0.0. So finally what you will get answer here, students? 2 into 10 to the power of 3, right? Now go back to the question. What is the equation?